Here is a video that leads us in constructing Lewis dot diagrams for polyatomic ions. A polyatomic ion has physically gained or lost electrons beyond being neutral. So therefore, the structures are just slightly different. Let's look at cyanide first. Here we have carbon bonding to nitrogen. So I'm going to go ahead and approach these as if I were them being neutral. Now, this has a -1 charge, so I must add an electron. Whenever there's a charge, I suggest adding it or taking away electrons from the center element. But here we don't have a center, so I'm going to go with the more electronegative element getting that extra electron. So now nitrogen starts with 6. So it needs 2 more to be stable. So therefore, I'm going to single bond, and why don't I go ahead and double bond. So then nitrogen 2, 4, 6, 8. Oh, but my carbon only has 6. Okay, we're going to have to resort to one of those coordinate covalent bonds. Nitrogen can donate 2 of its, and then everyone's good with the octet. But I must show that this structure has an abundance of 1 more electron. So therefore, I will put this in brackets. That's what you do for Lewis dot structures if anything is charged. It gets placed in square brackets and the charge elevated as we do with ion values. That's cyanide. All right, ammonium. Ammonium is the most common positive polyatomic ion, the only one that we really deal with. All right, so there's 5, and we'll bring in our 4 hydrogens. However, because it is +1, we'll remove 1 of those electrons we've assigned to nitrogen. So then isn't it perfect? We just need 4 single bonds, octet, hydrogen is satisfied, +1. Okay, how about nitrate? Well, nitrogen will come in with its 5, but I'm going to assign it 1 more because of that -1. Then oxygen, so everybody needs 2 more. Let's satisfy 1 oxygen at a time. So if then this oxygen is good, and actually my nitrogen is good. Now let's pause here to really emphasize something. Nitrogen, ladies and gentlemen, never ever exceeds its octet. Carbon, nitrogen, oxygen, fluorine, they never exceed the octet. We're going to find out that any element in period 3 and below can exceed the octet. They can have more than 8 that they're ultimately sharing. But nitrogen isn't one of them. So this will not go over 8. And as we have it bonding, it is. So let's let each of these oxygen keep the 6 that we originally assigned it. And let's use these electrons from nitrogen to make our single bonds. So then nitrogen, which we had assigned 6 because of the -1, and its electrons now are 1, 2, 3, 4, 5, 6, but the sharing with this oxygen gives it 8. Everybody has 8, but we need that. Okay, now sulfate. Sulfur can exceed the octet. So we're going to come back to do sulfate in a bit. All right, but I want to show you something with nitrate. Nitrate does something called resonate. So if we go back to the structure that we just had, all right, Now, I chose this oxygen on the right to make the double bond, where someone else in class may have chosen it here, someone else may have chosen it here. Double bonds have a shorter bond length and a greater bond energy. If we have a greater bond energy, that means this type of bonding is slightly lower in energy than these. Well, why is this oxygen getting to partake in the lower energy? And again, another student may have drawn it here, another student may have drawn it here. So what prioritizes which oxygen? Well, actually, when we measure this in nature, the bond between the nitrogen and all of these oxygen is not as short as a double bond or as long as a single bond. It actually is just a bit shorter, such that this double bond is momentarily shared between these three different oxygen. It's as if the very next moment that we look at this molecule, if the first time the double bond is here, the very next moment it rotates to be there. And then the very next moment it rotates to be here. Such that there is an equal bond length throughout this whole entire molecule. So the way that we would show resonance is this bond is rotating, is taking turns amongst these three oxygen. Now, of course, if one of these were a hydrogen, well, nitrogen can't double bond with it. So resonance is usually found when a double bond could have been made elsewhere within the molecule. So most times we're going to see it in AP Chem where you have your center atom bonded to more than one element that can partake normally in multiple bonds, like oxygen, like nitrogen, like sulfur. Those are the main ones that we're going to see most often. So it really is like, okay, each of the sharings is like a single bond and like a third of a double, because it's alternating so quickly that the length of this would not be as long as a single, would not be as short as a double. It would kind of be like a third of the way, because it's being shared between three oxygen toward a double bond. So if perchance there is resonance, we need to show all the possible structures. And quite honestly, usually the question identifies that. Like it might read, construct the Lewis dot structure for nitrate showing all resonance structures that can exist. So you're kind of given the hint or trigger words within the question to let you know when this can be possible. So we talked about constructing for polyatomic ions, and we also showed the circumstance of resonance. The next video will address elements that can exceed the octet, and then help us to know, well, how do we know what is the right structure then? How much will be exceeded, and will it exceed the octet? And then we incorporate something called formal charge. Thank you.